Today, class, we're going to talk about the Pythagorean Theorem. But in order for us to do that, there is one prerequisite that we have to know. We have to know how to calculate square roots. So what we're going to do here, it says estimate each square root to the nearest whole number. Well, what we're going to do is we're going to use our calculator to find this answer. Okay, so we need to make sure that we understand how to type in a radical into the calculator in order to be able to do the Pythagorean theorem. So let's get our calculator and let's see if we can do that. If you remember from a previous lesson, we talked about square root as being right above the x squared key. It's right here on the calculator. So in order for us to type in the square root of 18, what we're going to do in order to get to that, because it's blue and it's above the key, we're going to press the second key. So I'm going to press the second x squared, and now we're ready for typing in the square root. Now in the calculator that we use in class, it does not give you the parenthesis. It just gives us a box here underneath the radical. And you'll type in the number, and then you will hit enter. Okay? And if you hit the right arrow key, it will come out of the radical. Okay? So on my calculator, it will put the parenthesis. Anything inside the parentheses is considered underneath the radical. So this first one here says the square root of 18. So we'll type in 18, close the parentheses, and then hit enter. And I end up with 4.2 as my answer. Okay, so this one is approximately 4.2. But it says write this to the nearest whole number. So this 0.2, is it big enough to do anything to the 4? No. So again, this would be approximately 4. Okay. For the square root of 26, we do the same thing. We bring our calculator back up. We do the second x squared, type in the 26, close the parentheses, hit enter. We end up with 5.09, which is 5.1, which rounded to the nearest whole number would be approximately 5. Okay, so that's all we're going to do as far as doing those right there. But we should be able to be familiar with that. Okay, now this one was 5.09. So if I asked you to round that to the nearest tenth as opposed to the nearest whole number, this 9, it is big enough to do something to the 0, so it makes it 5.1. Okay, so just make sure you understand your rounding rules. So today what we're going to do is we're going to talk about the Pythagorean Theorem. So we're going to learn to use the Pythagorean Theorem to find the length of a side of a right triangle. We need to make sure that we understand that the Pythagorean Theorem will only work with right triangles. It will not work with any other shape or any other figure, only a right triangle. We need to remember that in a right triangle, we denote the 90-degree angle with a little box. Now, when using the Pythagorean Theorem, we have some names for our triangle. It says in a right triangle, the two sides that form the right angle are called legs, this angle and this angle. Okay? The side opposite the right angle is called the hypotenuse. This side right here, the right angle symbol points to the hypotenuse. Okay, so it will always be over here on the opposite of the right angle. The hypotenuse will also be the longest side of the right triangle. It says one of the first people to recognize the relationship between the sides of a right triangle was a Greek mathematician named Pythagoras. This special relationship is called the Pythagorean Theorem. And here's what the theorem states. It says in a right triangle, the sum of the squares of the lengths of the legs is equal to the square of the length of the hypotenuse. So in other words, if I take whatever number this happens to be and I square it, I take this number right here and I square it. If I were to add these two numbers together, squared, I'm going to get this side here squared. So that's what this stands for. A squared, so we'll take, if this were, let's say this were a 4, then I'm going to do 4 squared. And if this right here were a 6, then I'm going to do 6 squared. Well, if I were to add 4 squared and 6 squared together, I'm going to get the value of c squared over here. Okay, so that's what we need to understand. Okay, that's basically what the Pythagorean Theorem states. And this guy named Pythagoras, he came up with this idea, and it works for every single triangle. So let's see if we can answer a few questions. Here's our first one. Okay, it says, use the Pythagorean Theorem to find the missing measure. So we're looking for C right here, which is called the hypotenuse. So the first thing that I want you to do anytime you do one of these problems is I want you to write down the formula. Okay, so a squared plus b squared equals c squared. Now what we're going to do is we're going to plug in our values. Now a and b, the two legs, it does not matter which one you call a and which one you call b because you're adding them together. Okay, so I'm going to take this 12, I'm going to let it be a. Okay, so this is going to be 12 squared. I'm going to let the 16 be the b, so plus 16 squared equals c squared. So now we do our math. Well, 12 squared, when we do that, it means 12 times 12, which is 144. Well, 16 squared, I may not know that one, so I'm going to get my calculator back out, okay, and I'm going to actually do that one. So 16 squared, there's several ways of doing it. One way is just doing 16 times 16 and come up with the answer of 256. Another way is do 16 and hit the x squared button, and it puts the little square there, and you get the same thing. The third way that you can do an exponent is using this key right here. This is called our exponent key. We hit that little key and then hit the 2, and that will also give us 256. So there's three ways that you can evaluate a number squared. So 256 equals c squared. So now we do the math. We add these together. So we go back to our calculator and we do 256 plus 144. Oops, hit one too many. Okay, and then hit enter, and we get the answer of 400. So 400 equals c squared. Now, I don't want to know c squared, I want to know c. Well, we know based on our calculator that the opposite of squared is actually square root. So to turn c squared into just a c, what I do is I just take the square root of it. And if I take the square root of one side, I'm going to take the square root of the other as well. So c squared, or the square root of c squared, is equal to c. And this is where we go back to our calculator. And we have to do the square root of 400. So we do second x squared to get the square root, 400, close parenthesis, equals, and we end up with an answer of 20. So our answer is 20 centimeters. Please remember that when we're doing these problems, if there is a label, you have to give me the label. Let's try another one. So here's one more that's just like that. We do the same thing. A squared plus b squared equals c squared. We plug in our values. Again, a and b, it doesn't matter which one you call which. So 11 squared plus 15 squared equals c squared. So we do our math. 11 squared is going to be 121. 15 squared is going to be 225. Okay, so let's just double check that to make sure. 15 squared, 225 equals c squared. So we add these two together. So 225 plus 121. And remember, if we just had that up there, we can just hit the plus. It will give me the previous answer. We add them together, and we end up with 346 is equal to c squared. Now again, I don't want c squared, I just want c. So I take the square root of it, and I end up with c equaling or being approximately. We could actually put the squiggly equals there. So we do second square root, 3, 4, 6, close parenthesis, enter. I end up with 18.6. Now what I'm going to want you to do on this assignment is round to the nearest tenth. Okay, so we've got this number right here. This number is in the hundreds place. I use it to determine what to do with the 6. So this 0, it's not big enough to do anything, so it's just 18.6. And it's going to be 18.6 centimeters. So that's how we answer a Pythagorean theorem problem if the hypotenuse is missing. Well, what if one of the legs is missing? Like this one right here. Well, we start off exactly the same way. We start off by writing down the formula. And we plug in our information. But this time what I know is, since b is missing here according to this, 5 has to be the a. So I'm going to do 5 squared plus b squared equals 13 squared. This is where you're going to have to kind of remember some things from last year when you did equations. Okay, so we do the math. 5 squared is going to be 25 plus b squared equals 13 squared is going to give me 169. Well, I need this b to be by itself. So we need to remember, what is it that I'm going to do with this 25 in order to get b squared by itself? Well, what we have to do is we add its opposite. So I'm going to add a negative 25 to this side. And we've learned that whatever I do to one side, I have to do to the other as well. So I'm going to add a negative 25 to this side also. Okay, so my 25s on this side will cancel each other out, and I'm left with b squared. And now I have 169 minus 25. Well, when I do the subtraction there, I actually end up with 144. So, same kind of thing we did on the previous problem. To find b squared, or to find b out of b squared, I take the square root of it. So, b squared turns into b, and the square root of 144 is 12, and in this case 12 centimeters again. Okay? So let's try one more where a side is missing, and then we're going to do an application problem, and then we'll be done. Okay, so here's another one where the b is missing. Now that could be an a. Remember, a and b, it doesn't matter which one is which. Okay, so this time again it says it's b. So a squared plus b squared equals c squared. Okay, the 3 is going to be our a, so 3 squared plus b squared equals 5 squared. The 3 squared gives us 9 plus b squared equals 5 squared gives us 25. So now again, I need to get rid of this 9 because I need my b squared to be by itself. So I'm going to add its opposite. And if I add its opposite to one side, I have to add its opposite to the other. Okay, so my 9's subtract out, and I'm left with b squared is equal to, and 25 plus negative 9, our signs are different, so we subtract, and we end up with 16. Now again, I don't want b squared, I just want b, so I take the square root and find out that b is equal to 4, and in this case again, centimeters. Okay. Now let's try an application problem, because you can actually use this in the real world. Okay, so here is an example. A rectangular field has a length of 100 yards and a width of 33 yards. About how far is it from one corner of the field to the opposite corner of the field? Round your answer to the nearest tenth. So in this one, they didn't provide us with a picture, so we may need to do so. So this side right here is 33 yards. Okay, this side right here, this is not drawn to scale by any means. Okay. This side right here is 100 yards long. Okay, and what it says I want is, what's the distance from one corner to another? So I'm looking for this corner to that corner right there. Now just imagine those meet. And it would be a 90-degree angle because it is a rectangular field. Okay, so again, in this particular problem, what piece is missing? Well, I know this side and I know this side, and they're both touched by the right angle. So these two are legs. So that means one of these sides is an A and one of them is a B. And what's missing is the C. So a squared plus b squared equals c squared. We plug in our information. 100 squared plus 33 squared equals c squared. So here's where we might want to do some math here. We may not remember this. So 100 squared gives us 10,000. Okay. 2 zeros here, 4 zeros here. Plus 33 squared. So 33 times 33. Uh-oh. Clear those out there because I hit way too many 3's. So just do 3, 3. I'll just do this one. Squared. Enter. We end up with 1,089. And that's what c squared is equal to. So in the real world, sometimes our numbers are not very nice. So we add these together. So 1,089 plus 10,000 equals, and we end up with 11,089. Now again, I don't want c squared, so I take the square root of both, and c is approximately equal to, and we do the square root of that, so second x squared, 11,089, close parenthesis, enter, and we end up with 105.30. The problem says round to the nearest tenth, So we look at the hundredths place. The 0 is not big enough to do anything to the 3, so our answer is just 105.3 yards long. Okay, now that's how we do the Pythagorean theorem.